Assalamualaikum and hello everyone. Today we're going to go through the mechanism for benzene. Now benzene undergo electrophilic substitution. Okay. So here benzene undergo electrophilic substitution. It means here it involves the productions of electrophile. Okay, and why is it substitution is because the hydrogen in benzene will get replaced by your electrophile. So here it says that the mechanism involves the productions of an electrophile. Again, recap your AS knowledge. What is electrophile? It is a species that can accept a pair of electrons. Now electrophile usually it is a positive ion. Okay, and then they are lacking in electrons. That's why they can accept pair of electrons. One pair means 2 electrons. Okay. So let's take a look on the first example, halogenation. Now I'm choosing the reaction between benzene and bromine. This reaction requires anhydrous FeBr3 catalyst. Okay. What's the reason that we need this catalyst is because this FeBr3 will help you to produce your Br plus electrophile. Okay, so first one, the productions of the electrophile, which is Br plus, happen when your FeBr3 catalyst polarize the Br2 molecules. Now, what it means by this one, remember Br2 is a non-polar molecule. They shouldn't have this delta plus delta minus thing up here at first, but if they are closer to FeBr3 it will get polarized. That's why now they have delta minus and delta plus charge. Okay, next one is that these Br2 molecules will form a dative bond with FeBr3, where next one is that it becomes FeBr4 minus for this one, and the other one, which is the one Br delta plus, is the one that gonna form the Br plus electrophile. So this is the one that we need. Now also remember how can Br2 molecules form a dative bond is because remember iron Fe, iron is a transition element, so they have a vacant 3d orbitals. Okay. So this one is only to show you that you form the electrophile. We need this electrophile for the mechanism. Now, here is the actual thing. So when you have benzene and you have the electrophile, remember electrophile recap, it accept pair of electrons. Okay, so Br plus will accept electrons from this benzene ring. So benzene ring will have to open up this ring. Okay, share one of the one pair of electrons with your Br plus electrophile, and it forms this bond. Okay, and remember originally the first carbon here is also attached to hydrogen. This is the original one, but at the same time the Br is also attached to the first carbon, and then you form that bond. Okay, now if you do realize here, since you already share pairs of electrons with Br plus, you are disturbing the ring of the benzene. Okay, so when you draw it, you need to draw an arc to show that it opens up the ring and share the electrons with bromine. Now how to draw this arc, you have to be specific because bromine is attached to this first carbon here. Therefore the arc should be from the second carbon up till the 6th carbon there. So you don't just simply hantam the arc. Okay, you don't just put like C here. No, it must be from the second carbon until the 6th carbon there, because your bromine is attached on the first. Now since you already share the electrons with the bromine here, it becomes a plus charge for the ring. We want to restore back this ring. So what happened is that you take the electrons from the bonding of carbon and the hydrogen and you give it back to the ring so that it will become a complete circle again. So you restore your benzene ring, and then your hydrogen here will become H plus. Now this H plus will take one of the bromine, okay, and become HBr. This is your side product, and since you give one of the bromine to your H plus, this will become FeBr3, and if you do realize, you are forming, regenerating back your catalyst. Remember, catalysts, they are not used up at the end of the reaction. So you complete already the mechanism. So again, the first one is to show the productions of electrophile. Next is that it will react with benzene. Electrophile will accept electrons from benzene, pair of electrons from benzene. So this ring will be open up. Okay, remember it's from the second until the sixth carbon. Okay, and it has the positive charge. Now, since you already share the electrons to your electrophile, so you form that bond between the first carbon and Br, and at the same time you also have the carbon and the hydrogen. This is the original one. Now you have to restore back the ring, so you give the electrons from the bonding to the ring and it will restore back your ring. This hydrogen will become H plus. H plus will take one of the bromine from the production here, FeBr4 minus, then it will become HBr. So this is your side product and you will get back your catalyst. Now the second example is alkylation, Friedel-Crafts. Now for the alkylation, we want to produce a carbocation that will be your electrophile. So here I'm choosing the reaction between benzene and halogenoalkane. Okay, and then the catalyst is AlCl3. First one is that you can see here your carbon and Cl. Cl is more electronegative, therefore it has a delta minus charge, and carbon here have a delta plus charge. So electron will move to the Cl, and this Cl will form a dative bond again with your catalyst. That's why you produce AlCl4 minus. Now this one, since you already break the bond here, your carbon only have 3 covalent bond. So you call this carbocation. So that's the one with the positive charge. Okay, the second carbon has that positive charge. This is your electrophile that you need. Once you already produce your electrophile, the same thing. You just react it with your benzene. Again, electrophile need accept that lone pair of electrons. So from the ring, okay, it will get the electrons, the lone pair of electrons, and it form the bonds. Now since this benzene give that electron, you have to open up the ring. Again, remember, since CH2, CH3 is attached on the first carbon, your ring starts from the second until the sixth carbon. Okay, now how do we restore back the benzene ring? As usual, from the bonding here, the electron, you give it back to the benzene. Okay, so you restore back your benzene ring. Now this hydrogen is already got substituted with CH2, CH3. This hydrogen will become H plus, and it will take one of the chlorine from this ion. Okay, and it become HCl. This is your side product. Now since AlCl4 minus already give one of the chlorine to your hydrogen, it will become AlCl3. And if you do realize, AlCl3 is the catalyst that you get back. Okay, catalyst is not used up at the end of the reaction. So I hope that this is useful for you. Apply it to do your worksheets, and then make sure that you submit your worksheets by the end of the lesson. Thank you.